everybody, this is Mr. Shaban, and today we're going to have another lesson in the science curriculum for year 9. In today's lesson we are going to take some questions based on the lessons that we have discussed earlier. We're going to discuss some of the workbook questions, and we're going to have past paper exercises. We're starting with the first question. Here, as you can see, we have a structure of an atom, and they are asking us to label the diagram of the atom. So basically, as you know, that all the stuff which is found around us are built of tiny particles. These particles are called atom, and it consists of, as you can see, different particles with different charges. So we have a negative charged particle over here. I want you to figure out the name of that particle. Which particle out of the 3 particles found inside the atom has a negative charge? Yes, it's electrons. Electrons are the particles which are charged negatively, and they are found in the energy levels surrounding the nucleus. So this core is called nucleus, and nucleus consists of 2 different particles. We have a blue one and we have a green one. The blue one has no charge. So which one of the 3 particles found inside the atom has no charge or uncharged particle? I want you to think about it. Yes, perfect. It's neutrons. So neutrons are particles that have no charge and they are found in the core, and this is going to leave us with the last particle found inside the atom, which is positively charged, and it's called protons. So as you know, we have in the core, we have uncharged particle, which is neutron, positive charged particle, which is proton, and the nucleus is surrounded with energy levels which contain negative charged particle, which are electrons. Perfect. An element is made up of only one type of atom. So any element which is found around us, gold, silver, copper, each element has a certain kind of atoms. We have around 100 different elements found in nature, and these elements are organized in the periodic table. A compound is formed when 2 or more different atoms are chemically bonded together. As an example, we have hydrogen, an element called hydrogen, and an element called oxygen. Both hydrogen and oxygens are chemically combined together. So we can say that this H2O is a compound, is not an element. This compound consists of hydrogen and oxygen. As you can see over here, next to hydrogen we have 2. So we can say that we have 2 atoms of hydrogen, and over here we have no number written next to the oxygen, so we can say that we have 1 atom of oxygen. If we don't have any number, so we'll consider it as 1. Compounds can be represented by the chemical formula, which is the H2O. This shows the number of atoms of each element present in the compound. So let's see the first exercise. Here we have a table. This table has different substances and has some chemical formulas along with the number of atoms of each element. We're starting first with water. Water has a chemical formula of H2O. Good. H2O, as you can see, we have discussed that earlier. Hydrogen has 2 electrons, has 2 atoms, and oxygen has no number written next to it, so we're going to consider that as 1. So 2 hydrogen and 1 oxygen. Number of atoms of each element. Here we have 1 magnesium and we have 1 oxygen. As we have discussed earlier, any compound which is going to have 2 elements, one of them is oxygen, we're going to call it oxide. So we have 1 magnesium, 1 oxygen, so we can call the substance as magnesium oxide because it's 1 magnesium attached with 1 oxygen. Perfect. And the chemical formula, as you have guessed it correct, we're going to write Mg, and next to it is O, so MgO. That's the chemical formula for the magnesium oxide. The second substance is carbon. It has a chemical formula of C. Can you find any number written next to it? Yes, perfect. We have no number written next to it, so we're going to consider it as 1. Perfect. So we have 1 carbon. Here we have 2 oxygens. So we have a substance which consists of 2 oxygens. So we can say that the substance that we have is pure oxygen, and we can call it oxygen. Okay, so it has nothing mixed to it. When we're going to write it is oxygen, 2 atoms, so we're going to write here O2. So O2 is the chemical formula for the oxygen molecule. Over here we have methane. Methane consists of CH4. I want you to guess it. Do you have any number written next to the carbon? Yes, you have guessed that correct. It has no number, so we have 1. And for the hydrogen, we have 4 written next to it, so it's going to be 1 carbon and 4 hydrogen. Perfect. For the iron, iron has only 1, so which substance should it be? It should be iron as well. And the symbol of the iron, if you're going to check your periodic table, is going to be, as you have mentioned, Fe. Perfect. Glucose consists of C6H12O6. So let's see the number of atoms per each element. C stands for carbon, and we have 6 copies of the carbon. Hydrogen has 12 written next to it, so we have 12 atoms of hydrogen. Oxygen has 6 written next to it, so we have 6 oxygen atoms. So we have 6 carbons, 12 oxygens, and 12 hydrogens and 6 oxygens. Over here we have 1 hydrogen and we have 1 chlorine. So the substance is going to be hydrochloric acid. The hydrochloric acid is going to be written as HCl. 1 hydrogen, so nothing is going to be written next to it. 1 chlorine, so nothing is going to be written next to it. Then we have sulfur dioxide. Sulfur dioxide consists of SO2. So how many atoms for sulfur? Nothing written next to it, so we give it a 1. Perfect. Oxygen has 2, so we're going to write it 2 oxygens and 1 sulfur. Perfect. You have mastered how to figure out the number of atoms per chemical compound, which is so perfect. I'm so proud of you guys. Let's see the second question, or the third question. Third question over here, we have different substances. As you can see, all of these are substances, and what you need to do is to put them into an order, into elements or compounds. So I'm going to give you like 3 minutes in which you're going to use in order to place them in order. Elements for the element column and compounds for the compound column, and then we're going to revise the answers together. So let's double check the answers. We have the aluminum. Aluminum, the first one, is it one substance or more than one substance, one element or more than one element? It's only one element, so we're going to place it in the element column. Then followed by the next one is boron. Boron is also one element. We have nothing written next to it, so it's a pure element. Then we have another element. I want you to go through it. Carbon dioxide is not one. Calcium carbonate is not one. Copper sulfate is not one. But hydrogen is one element, so we place it in the element section. Then we have hydrogen peroxide. Hydrogen peroxide is hydrogen mixed with another element. So we cannot place it in the element, but we have magnesium. Magnesium is only one element, so we place it in the element section. Sodium chloride. Sodium chloride, as you can see, it's sodium and chlorine. So these are two, but we have sulfur. This can be considered as an element because it's only one pure substance. Then after that we have tin. Tin is a pure element which it can be added to the element column. At the end we have zinc oxide. Zinc oxide is zinc along with oxygen, so it's not a pure element. For the compound, we're going to go through any substance which has more than one element. So let's check. Aluminum is one, boron is one. Carbon dioxide, here we have carbon and oxide stand for oxygen. So the first compound is carbon dioxide because it's carbon, one carbon atom mixed with di, which is two oxide oxygen. So one carbon mixed with or chemically bonded with two oxygen atoms. Then calcium carbonate over here. Calcium carbonate, we have more than one element. We have the calcium, we have the carbon, we have the oxygen. You remember from year 8 we said any 8 which is going to be placed in a name represent a compound which is made up of 3 elements. One of them is oxygen. So calcium carbonate is a compound which can be placed in the compound area. Then followed by sodium chloride. Sodium chloride is also a compound that can be placed over here because it consists of sodium and chlorine. And then we have the copper sulfate. Copper sulfate consists of copper and sulfate. It's like sulfur along with oxygen because 8 represent a compound that has 3 elements. One of them is oxygen. And then we have hydrogen. It's only pure element, but hydrogen peroxide, hydrogen and oxygen, so we can place it in the compound hydrogen peroxide because it's 2 elements are chemically combined together. Magnesium is a pure metal. Sodium chloride, we have mentioned that in the compound. Sulfur is pure, so we place it in element. Tin pure, we place it in element. And then zinc oxide. Zinc oxide is zinc mixed with oxygen, so we place it in a compound section. I hope you have mastered how to put the elements apart from the compounds. It's based on the elements. If it's pure, nothing or no more than one element is mixed together, that's an element. If we have 2 or more elements are chemically combined together, that's a compound. Here we have another exercise which is going to represent the molecules by the help of the particle theory because we're going to need them in the chemical reactions. So over here we have for each of the substances below, draw a particle diagram to represent one molecule of the substance. Use the key shown below. The first one has been done for you. So water consists of 1 oxygen and 2 hydrogens. I'm going to give you 1 minute in order to figure out the answers for these questions, and then we're going to revise the answers together. Perfect, guys. I hope you have answered the questions right. Right now, I'm going to revise with you the answers. Over here, we have carbon dioxide, 1 carbon and 2 oxygens. So I'm going to look for the carbon. Carbon has a black circle, while oxygens have a red circles. So it's going to be something like that, a black circle in between, 1 oxygen on each side. Ammonia consists of nitrogen and 3 hydrogens. So we're going to get the blue circle in the middle. This should need to be blue, and 3 hydrogens surrounding it, and then oxygen, 2 red circles need to be next to each other, and then hydrogen, 2 white circles need to be next to each other. Please recolor this into blue. Okay, then we're going to look for the course book questions, the workbook questions, exercise 4.1. Get the first question, the structure of the atom. The first question, label the diagram of an atom. As we have discussed that earlier, we have a core. This core consists of 2 different particles. The first one is positive charged particle, which is called proton. The second one is uncharged particle, which is called neutron, followed by the red particles, which are electrons. Okay, so electrons are around the nucleus. Inside the nucleus, we have positive protons, uncharged neutrons. Then we're going to take the workbook questions on page 43 and 44. Here we have an experiment which is stand for the Rutherford, and the first question, complete the diagram to show what happened to the particles when they hit the golden foil. Second question, what did the result of Rutherford's experiment tell him about the structure of the atom? Third, name another scientist whose work contributed to the model of the atom we use today. I'm going to give you 2 minutes in order to figure out the answers for these questions, and then we're going to revise them together. Okay, guys, for the Rutherford experiment, when they have fired the particles, majority of the particles went through the golden foil without deflecting or reflecting, and then very few particles got deflected, which came close to the nucleus, and the particle that hit the nucleus got reflected back. Perfect. Second question, what did the result of Rutherford's experiment tell him about the structure of the atom? It tells him that most of the atom is space, that's why most of the rays went through, but we have a dense nucleus found inside at the middle of the atoms, that's why we have few deflected and reflected rays. Name another scientist whose work contributed to the model of the atom we use today. We have too many scientists, so we can give any credit for J.J. Thomson, and we have too many of them. You can take the marks for any of the correct name. Then exercise 4.2, more about the structure of the atom. I'm going to give you a minute in order to figure out the answers. It's so easy. You can use your periodic table in order to find out the answer for some of the questions, or you can use the data given in the exercise. Okay, guys, I hope you have figured out the answers. Right now, the first question, we have the element carbon has an atomic number of 6 and mass number of 12. A, how many protons does carbon have? We said carbon is going to have atomic number. This number represents the number of proton, number of electrons. So we have 6 protons and we have 6 electrons. How many number of neutrons? Remember, we said we get the mass number minus the atomic number. So mass number minus the atomic number is going to be 12 minus 6 equal 6. Right now, draw and label the structure of an atom of carbon. As you have it over here, we have 6 protons, 6 neutrons inside the nucleus, and surrounding them 6 electrons, 2 electrons in the first energy level, followed by 4 electrons in the second energy level, I want you to remember that the first energy level takes only 2 electrons, and whatever is left over is going to be added for the second level and third level and so on. So we don't move until we finish and complete the energy level. So we finish the first one with 2, second one take up to 8, third one take up to 8, and so on. Second question, complete the table below. We have beryllium. These are the data, atomic number, mass number, and they have given us the proton is 4, as same as the atomic number, neutron 5, because they have minus the 9 minus 4, and then number of electrons, they are 4. Electronic structure, first energy level takes 2, second energy level takes 2, because we have overall 4 electrons. Magnesium, we have the atomic number 12, mass number 24. So proton should be exactly the same as the atomic number, so we should have 12. The neutron, we should minus the 24 minus 12, so we're going to have 12 neutron. Electrons should be equal to the atomic number, and the proton should be also 12. For the electronic structure, we're going to put the first 2 electrons in the first energy level, and then followed by 8 electrons in the second energy level, followed by 2 electrons in the last energy level. So we have 12 electrons. We put the first energy level, take maximum 2 electrons. Then the other leftovers are going to go for the second energy level. It takes maximum up to 8 electrons. And then the 2 leftovers are going to go to the third energy level. Then calcium, we have atomic number of 20, mass number of 40. We have the protons. Proton should be equal to the atomic number, so we have 20. Neutrons should be mass number minus atomic number, so 40 minus 20 should be equal to 20. And the electron should be 20. For the electronic distribution, I want you to remember, first energy level take maximum up to 2. Second take maximum 8. Third take maximum 8. And fourth take the leftovers. So over here we have first energy level 2, then 8. These are overall 10. Then we still have 10 more. We place 8 and the third energy level. These are 18. We're going to have 2 leftovers to be placed in energy level number 4. I hope you have enjoyed today's lesson, and see you next time.